So here it is again. I wrote it down step by step for you. So in case you missed it, okay, because sometimes very, very important points are explained only within half a minute or so. And if you miss it, you missed significant parts. Okay, and so this is how coastal upwelling works for the southern hemisphere. You need longshore winds, okay, or winds that have a component pointing along the coast for a long enough time. Okay, I said several days. It creates offshore surface, Ekman transport, okay, and this lowers the coastal sea level because you move water away from the coast. Water is incompressible, and if you move water away from the coastal sea level drops, and it creates a sloping sea surface. The sea level decreases towards the coast, and instead of the water being just moved back under the influence of the Coriolis force, it creates a geostrophic flow which runs along the coast. This is shown here in this graph now by these black arrows. This creates a bottom Ekman layer because you have a current that interacts with frictional effects with the seafloor. You create a bottom Ekman layer, and the bottom Ekman layer flows opposite to that in the surface Ekman layer, and it actually creates an sort of overturning circulation. You move water towards the coast in the bottom Ekman layer. And you could, if long enough, you get upwelling near the coast. You get full upwelling if long enough, or you get partial upwelling. So here is also a list of all indicators that you have. Sea surface temperature drops near the coast by, can be in some regions up to 5 degrees. In warm water regions, you can only see it. Indeed, in regions where the subsurface water is colder, you can't see that. Coastal sea level drops by 5 to 10 centimeters. It's difficult to measure. You can't measure it directly. You can infer it from measurements. And you have to use certain filters. Because in sea level, you have several effects. You have wind waves, you have tides, and all that stuff all at the same time. Indeed, ocean color enhanced primary production levels, elevated chlorophyll A levels you can measure from space. And you might also infer the formation of a coastal jet. Okay, so you can do that from altimeter data. You can infer surface geostrophic flows. Okay, so this is really, really important, this bit. So this makes you a specialist in the understanding of wind-driven coastal upwelling. That would be cool.